All right, let's go. New unit, new me, right? Everything's going to be gold in this unit. So we're transitioning from algebra to geometry. So we're going to talk about translations today. How does a translation affect the properties of a two-dimensional figure? So that is a figure without height. Yeah, I guess. It's got a length and a width. It's just a flat thinger. All right, two definitions to start. Over here, what we've got here is this is the unit. So we're in a unit that talks about transformations. There's 4 different transformations. And when we transform a shape, what we're doing is we're going to change the shape. We're going to do a change in position or size or shape. And it could actually be all of those. We could change all 3 of those as a transformation, or it's a specific one of those things. So it's change in position or size or shape of a figure. And then for today, what we're working on specifically is a translation. So this is today's work. Today's work. Right? And for today's work, what we're doing is it's when we move every point the same distance and the same direction. There we go. Okay. Yeah. So we're going to move a shape, same distance, same direction. Nothing else is going to change with that shape. So if I have my eraser here, I can move my eraser around. The size of the eraser is never changing. The eraser is always the same. Everything else about the eraser is the same. I'm just translating it around this piece of paper, or technically like the coordinate plane. Let's look at our prompt. A landscape architect shows a plan for a new patio to a client. There it is. The client wants the fire pit moved 6 feet to the right and 3 feet farther from the house. Where should the architect place the fire pit? So here's our fire pit. Wants to move it 6 feet to the right and 3 feet farther from the house. How will the client's request change the fire pit? So if we look at this fire pit, we're going to change 6 feet to the right, 3 feet farther. Which property of the fire pit will the architect change? Are we going to change the size of the fire pit? Are we going to change the position of the fire pit? Are we going to change the shape of the fire pit? Are we going to change the orientation of the fire pit? Let me go back one here. There we go, that's better. Which of these 4 do you think it is? Go ahead and circle one. Good, all right, let's pick one. It's definitely position. So we're just moving the fire pit to a new spot. Nothing big is happening here. We're not rotating the fire pit. We're not flipping it upside down. We're not making it smaller. We're not making it bigger. We're just changing its position. So down at the next thing, what I'm going to do is I'm just going to draw an arrow here that says 6. There's our 6 feet to the right. That's better. And then 3 feet further from the house. That's going to give us a fire pit. That's about right there. Not the best drawing, right? But if it was the best drawing, it would be exactly the same as the other fire pit. What we should know about that fire pit at this point. When we look at that, if we go back to the actual fire pit itself, where's my thing? Oh, there it is. If we go back to the actual fire pit, and I just put some labels on here, let's say it's 4 feet by 4 feet by 4 feet. It's a square, which means in its new position, it's still 4 feet by 4 feet by 4 feet by 4 feet, despite my poor drawing. What we should also know is that if we look at the angles here, like that angle there, and that angle there, they have to be the same. So if this angle right here was 90 degrees, that angle right there has to be 90 degrees because the size and shape didn't change, only the position. All right, so when we move something, the angle measures stay the same, the side lengths stay the same. All right, flip it over, go into page 2. When we look at page 2, we're starting with a figure. We've got it in the coordinate plane. Let's get some vocab in here first. When we talk about moving these shapes, we have a pre-image. That's where we start. And then where we finish becomes the image. And what you'll notice is in the pre-image, our points are labeled with a single letter. In the pre-image, single letter. In the image, we get the same point name, but we add this little tick mark. I'm saying tick mark. And that little tick mark will say that that's A prime. That's our image location. Okay, on to the prompt. Polygon ABCD has vertices, and it's been graphed. I graphed it for you. What we're going to do is we're going to translate that image 8 units down and 3 units left. Okay, so all we're doing is taking each point, A, B, C, D, and moving it 8 down and 3 left. So let's start with D here because it's just the furthest to the left. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3. That becomes D prime. Now I'm gonna label as I go so I don't forget what's what. Here's C. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3. There's C prime. Here's B. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3. There's B prime. And there's A. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3. A prime. Now I'm going to get my straight edge, which has gotten under some papers. Here we go. Got my straight edge. Let's use a different color. Let me use the highlighter for this because that kind of shows up better on the camera. So get those lined up. Draw to draw. Get those lined up. Draw to draw. I think I mean to say dot to dot, not draw to draw. There's that one. And uno mas. There's that one. All right, so if you look at that, has the shape changed? No. Has the size changed? No. Have the angles changed? No. So if we look at this, the angle here, angle ABC is the same as A prime, B prime, C prime, the angle of that. Now over here, what I want to show you is this. Our original A, pre-image A, is -1, 6. And then our A prime becomes -4, -2. Now what I want to ask you about that is, what we ended up doing was we went left 3 and down 8. Now everything we do on the coordinate plane is number lines. They're just a series of number lines that have been laid on top of each other. If we look at this, we went from -1 to -4, that was left 3. We went from 6 to -2, that was down 8. Do you notice a relationship there? You might not, or you might already see it. But let me put another example here. This is not in the figure, 414. If I move 414, left 3, down 8, let me pause. If you have it, think about it. Left 3 would be 1. Down 8 would be 6. Have you figured it out? Well, that's good if you figured it out. So if I'm at -1, and I go left 3, -2, -3, -4, that's all I got here. If I'm at 6 and I go down 8, 5, 4, 3, 2, 1, 0, -1, -2, there I am. So what I did was I ended up subtracting, or I bring a negative value for left and a negative value for down. But if they were positive, then I would be adding those values. So that's a simple thing. We can do translation, and we don't even need a coordinate plane for that. Now to answer this question here, are all the side lengths and angle measures the same in both the pre-image and the image? Oh, this isn't my highlighter. Where's my highlighter? Here's my highlighter. There. Boop, 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 boop. Are they the same? Well, by definition, they have to be. Yes, because this is a translation, right? And the definition of a translation is just moving a shape's position, not its orientation, not its size, nor its shape. We're on to the last example. Quick and easy, lemon squeezy. What is the rule that describes the translation that maps trapezoid PQRS onto trapezoid P prime, Q prime, R prime, S prime? Okay, when we look at these two, we've got black and gray and black, Which one are we doing? Are we going from black to gray or from gray to black? Well, some very smart people in my classroom said, well, the arrows say we're going from black to gray. And that's true. But there's another way for us to know. Can you see what that other way is? Probably figured it out. We can see that this is just R, and this is R prime. And we know anything that has R prime on it, or has prime on it, that means that is the image. This is the second shape that's been created. So when we look at this, this also lives in a world of halves. So this point P here is halfway between this line and this line. And this P, of course, is also halfway between this side and this line. So what we're deciding is, has the shape moved up or down, and then by how many? Has the shape moved left or right, and by how many? That's all that we're doing here. All right, when I look at this, has it moved up or down? Definitely moved up. How much has it moved up? So I go a half, then a whole, then a half. So 1 plus a half, it went up 2. Did it go left or right? It went to the right. So now I'm here. I went a half, and then a whole. So that's 1.5. Ask a follow-up question about something we talked about before. Are all the angle measures the same in this? Yes. Are all the side length measures the same? Yes. Yeah. So we just have a simple translation that was up to right 1.5. All right. Hit that homework. You're going to be awesome. Good luck, you guys. Oh, yeah. And let me know if you have any questions. If you have any questions, you can ask. Okay.